Morning. Welcome to a special video where I just wanted to take a bunch of simple stuff we've talked about over the last couple of years. Well, not necessarily simple, but basic math that you've looked at, and I want to show you something really cool. Okay, so we're going to pull together some stuff from the Pythagorean Theorem, some basic geometry from Pascal's triangle, from polynomials that we're studying just now, and even a little bit of square roots. Okay, and we're going to learn about pentagons. Okay, so the first thing I'm going to do is I'm going to draw a circle that has a radius of 1. Okay, so that means every point on this circle is 1 unit away from the center here. Okay, make sense?
Yes.
And so I draw a triangle. If I pick any point, it has an x-coordinate and a y-coordinate. Does that make sense? The y-coordinate tells us how high it is. The x-coordinate tells us how far over this way it is. How do I find out how long the hypotenuse is here? What do I use? What math do I use?
The Pythagorean Theorem.
What does the Pythagorean Theorem say?
Well, it says a squared plus b squared is c squared.
Okay. So one side has length x, so that's going to be x squared. The other side has length y. That's going to be y squared. And how long did I say the hypotenuse is? How far is this point from the center? Well, so 1 squared, which is
same.
Hey, so we just learned that a circle with radius 1 that has a center here at 0, 0
Yes.
has an equation x squared plus y squared equals 1. That's pretty neat, right?
Yes.
Okay. Now, in later on down the road, there's a subject called trigonometry. And for this special case of a circle with radius 1, x and y coordinates sometimes have special names in terms of this angle instead. X is called the cosine of the angle, and y is called the sine of the angle. Have you ever heard of sine and cosine before?
Not much. I've seen them, but I haven't heard of them.
You've seen them, but you haven't heard of them. Okay, well, we're going to study something special today with a pentagon. Now, a pentagon has 5 sides, right?
Yes.
How many degrees are there around a circle? Do you remember? I'm going to do some basic
The
geometry.
circumference of the circle?
How many degrees are there all? If you make an angle that goes, well, let's do this. If you make an angle that goes halfway around the circle, so
That's
it's straight line.
180.
So how far is it all the way around the circle?
360.
360 degrees around the circle. A pentagon has 5 angles in the middle.
Yes.
So each one of those angles is going to be 360 divided by 5. And what is that?
For a regular pentagon.
Oh, sorry. Good point. Good point. A regular pentagon. Sorry. Regular pentagon. What's 360 divided by 5?
It's 72.
Good job. 72. Okay. So if I want to draw a pentagon, I just make an angle of 72 degrees, then I go 72 degrees over here, then 72 degrees over here, 72 degrees over here, and then I'm back to the start. And if I did this properly, this straight line should go right down there, and this should go right there. So I didn't get it quite right.
Big dot theory.
Yeah, big dot theory. Like that. And erase. Okay. So that's my pentagon, and each one of these angles inside should be 72 degrees. So obviously I haven't drawn it exactly perfect, right? But it's close. It's close, actually. Okay, so we're going to study these. And I'm going to go back and talk about cosine and sine. So, one of the things we know is the x-coordinate and y-coordinate of this point here. It's 1 unit away along the x-axis. So what's the x-coordinate?
X-coordinate's 1.
And how high up is it?
0.
0. And from there, I can write down an equation that's not going to mean much to you. This is the one part that's a little bit outside of what we've studied so far. I can say cosine of 5.
Not 7.
5 times this angle theta equals 1. Cosine's the x-coordinate. 5 times this angle is 360. The cosine here, which is the x-coordinate, is just 1. Okay? Alright, so this is what we're going to study, and we're going to learn something special about this angle here, which is 72 degrees. Okay?
Yes.
I'm going to turn the camera off and write some stuff on the board to not waste time writing it with the camera on. Okay, so we're back. Now, again, this is the one part we really haven't studied yet, but
Yes.
it's okay. This is just an equation, so it doesn't really matter. It turns out cosine to the 5th theta has a neat formula. Sorry, cosine 5 theta has a neat formula. It's cosine to the 5th theta minus 10 cosine cubed theta sine squared theta plus 5 cosine theta sine to the 4th theta. Now, have you ever seen the coefficients 1, 10, and 5 together before? That ring a bell at all?
Well, in Pascal's triangle, there's a row. 1, 5, 10, 10, 5, 1.
That's exactly right. 1, 10, 5. So we get a 1, a 10, and a 5 by counting every other coefficient. So these formulas for cosine and then similar ones for sine, can you guess which coefficients the sine formula is going to use?
These ones.
Probably those ones. Come in terms of the coefficients on Pascal's triangle, which is pretty neat. And then they have pluses and minuses, and those pluses and minuses relate to I, believe it or not. So there's a lot of neat stuff hiding inside of here, but we're not going to talk too much about that. Instead, we're going to say there's another way to simplify this formula, and it equals 16 cosine to the 5th theta minus 20 cosine cubed theta plus 5 cosine theta.
16, 20, and 5.
Okay, yeah, 16, 20, and 5 are a little bit of head scratchers. You don't usually see those together. But what I said is we have this angle and we multiply it by 5, and we get an x-coordinate equal to 1. Now the cosine that we were talking about was the x-coordinate up here, right?
Yes.
And that's what we're going to try to figure out. Okay, so I'm going to say cosine of 5 of this, which is 1, equals 16x to the 5th minus 20x cubed plus 5x, or 0 equals this minus 1.
This kind of looks like a polynomial.
Right, this is exactly what we're studying.
So-
Well, we're studying quadratics, but
Yeah.
these polynomials look exactly...
Yeah, we don't have any third powers or cubes.
Right, so the question is, can we see any easy solutions to this? Do you see any easy solutions to this? Do you see a number that solves this equation?
0.
0 doesn't.
I don't think 1. Let's see. Oh, what? 1 solved that actually.
Oh, 1 solves it.
16 plus 5 minus 21.
Now, we already know that the x-coordinate here is not 1.
Yes.
Okay, so we're going to factor out an x minus 1, and I'm just going to write down what that is because we don't need to show everybody that. So I got 16x to the 4th plus 16x cubed minus 4x squared minus 4x plus 1. Now, this is something that is going to be hard for us to eyeball and see, but one of the solutions inside of here is going to give us the solution we have up here. So now we're back to some interesting basic geometry. Remember when I said these lines went straight down here in a regular pentagon? That means the x-coordinate here and the x-coordinate here are the same.
Except that this one's negative.
No, the y-coordinate's negative.
Oh,
The
yeah.
x-coordinates are the same, and the x-coordinates are the same over here. This x-coordinate's negative. Doesn't look like it's the same as this one, but it could be. But now I have two x solutions that are same and two y solutions that are the same. And that insight, remember when you had parabolas that had two solutions that were the same? You had things like x minus 1 squared, or I, of course, just drew x squared.
Yeah.
Maybe this is something squared. Maybe this is x minus 1 times ax squared plus bx plus c squared. So this is what we are just studying right now, right?
Yes.
And we guess, because we have an x to the 4th, 16x to the 4th, we guess this would be a 4. Now, with a 1 over here and these negatives, this is either going to be plus or minus 1 if this is a square.
Yes.
Of course, I could have chosen this to be negative and this to be positive, but I'll just do it like this. But we can play around and solve this. This is just a little bit of algebra.
Yes.
Okay? Not that interesting, but you can play around with it. Not that interesting for the video. And it turns out that it's 4x squared plus 2x minus 1 squared.
Interesting.
Okay, hey, look, we now have a quadratic. Okay, let's
Yay.
turn off the camera for a second. Okay, so now we have a quadratic, believe it or not. Just with all this, nothing more than just playing around with a little bit of algebra.
Yes.
Okay? Now, we have not learned how to solve this yet. Okay, Doesn't look like 1's a solution. Doesn't look like anything really easy is a solution. It turns out the solutions to this are x equals -1 plus or minus the square root of 5 divided by 4.
Ah.
Okay? Now, 1 minus the square root of 5 over 4 is definitely negative, right?
Mm-hmm. Yeah.
That must be the x-coordinate here. 1 plus the square root of 5. The square root of 5 is bigger than 2, right?
Yes.
So 1 plus the square root of 5 is positive divided by 4. That must be here. So we just found out how to make a pentagon, a regular pentagon. We draw a circle with radius 1 and we pick a point here. And then we find the x-coordinate here. That's -1 plus the square root of 5 over 4. And we draw a vertical line. And these points are going to be parts of our pentagon. And then we have a point over here, which is -1 minus the square root of 5 over 4. We draw those points there and there.
And we connect.
And we connect the dots.
Connect the dots.
And we have a pentagon. So now we have a basic geometric shape, a pentagon. It has square roots in it. We figured out those square roots from polynomials. Turned out those polynomials came from Pascal's triangle. Turned out the idea from Pascal's triangle came from a little bit of basic geometry, that we had to be straight up and down. And some of that basic geometry was the Pythagorean Theorem.
Yikes.
That's pretty neat, right?
Yeah.
So that's pretty neat. So you just learned, and remember what x was. It was cosine of 72 degrees is -1 plus the square root of 5.
Yes.
over 4.
Yep.
That's pretty cool.
Yes.
It's pretty neat. This is the kind of stuff we're going to get to, down the road. But you can see the building blocks for this. Complicated or not too complicated?
Not too complicated.
Not too complicated, and this is what we're building up. Good job, sweetie. This is some of the really neat stuff you can learn studying math.